looked at different ways of organizing qualitative data, and what do we mean when we say qualitative data? Qualitative is the non-numerical stuff, things that's just descriptive. So like we did M&M color, like that's not numerical. So we talked about making a frequency distribution, which was just a table that listed the outcomes and how many times you got each outcome. What's a relative frequency distribution?
It's out of 4, and it's like how many, it's kind of like the percent before you turn it to a percent.
Yes, it's like that decimal part, the decimal version of a percent. So when we took our count and divided it by our total. We talked about reading like bar graphs, pie charts, side-by-side bar graphs. So we've talked a little bit about making those. My emphasis is going to be more on reading them than making them. So we just need to make sure we understand that. So those are all great things if your data is non-numerical. But if our data is numbers, that may not be real helpful. For instance, if I gave a test and I wanted to make a bar graph of everyone's score on the test, could everybody get a different percent on the test? Yeah, so would that bar graph really be very helpful for me? No. So we need other ways to organize that data. Let's start with this one. The following data represent the number of available cars in a household based on a random sample of 50 households. I want a frequency and relative frequency distribution. Okay, so do you remember what those things were? We just recapped it. What was the frequency? Huh? So here I'm counting number of cars. And we're going to list the frequency, how many times we got that. Okay, my different car outcomes, it looks like we have 0 through 5. All right, so now how many times do we get 0 cars? 4. Okay, how many times do we have 1 car? Yep. 2 cars. 3 cars. 7. 4 cars. 3 times. And 5 cars once. Okay. How could I quickly check if I got them all? Add them up. We said that there were 50 households. Does this add up to 50? Close enough. All right. So that's my frequency distribution. Then how do we get the relative frequency?
Divide the frequency by total.
Right. So it would be each of these divided by 50. We typically do the decimal on that. A fraction in lowest terms is also acceptable, but decimal is more standard. So 4 over 50, 2 over 25, or 0.08. 13 over 50, 22 over 50, 0.7 over 50, 3 over 50, and 1 over 50. And if I wanted to check myself again here, what should our relative frequencies always add up to? 1. All right.
How are there 6 decimals?
ask you questions from this distribution. What percent of the households have one car? What percent of the households have at least 3 cars? What does at least mean?
3, 4, 5.
We have to add those together. So I could ask questions, you might have to add things together in order to find it. Alright, so this is fine for that kind of data because the number of cars available, that's discrete, right? So we had nice numbers to work with, but if I were doing something that involved decimal values, it would be much harder to make this kind of frequency distribution. So some of the other options we have, one involves making a histogram. So a histogram is like a bar graph, but the bars are touching, so you squeeze them in, and each rectangle represents a class of data instead of just a singular data value. So it might be one bar represents everything between 0 and 3, and the next bar might be everything between 3 and 6, and so forth. With that, the height is either your frequency or relative frequency, just like with our bar graphs yesterday. The width has to be the same for every rectangle. So if it's a width of 3, they all have to be, they are touching. The classes are the groups, or the way we group our data. So we use that if we either have a lot of discrete data, so not something like number of cars, because nobody has, or very few people have, 12, 75, 100 cars, right? We're not going to keep going forever. But if we had something that had a large number of values, if they could be anything from 0 to 10,000, that's a lot of values. We might need classes to help make that more manageable. Or when we have continuous data, we use them. So I'm going to show some examples here in a bit, but we are also, with these histograms, going to talk about the shape of them a lot. A uniform distribution is when the frequency is evenly spread out. So if you look at the next slide, I put pictures of each of these. So a uniform, this is a histogram. The bars are touching. How wide is each bar? 2. Everything has a width of 2. We can tell this is everything between 0 and 2. That's between 2 and 4, so forth. It's uniform because everything has the same height. So it just creates a rectangle. Bell-shaped, we'll talk about that one a lot throughout this semester, is when your highest frequency occurs in the middle and it tails off on both ends. So I can see this kind of resembles a bell. I have my peak in the middle and both ends are pretty well the same. Okay, maybe not perfect because in real life is data ever perfect? No, but they'll be close. Or our data could be skewed. So skewed is when you have a peak and the tail extends off in one direction. So here I see, here's my peak, but I have a lot more points trailing off to the right, so that's called skewed right. Your tail extends really far to the right. This one is skewed left because the tail extends to the left. So those are really the only 4 shapes that we can look at. Uniform is very rare that everything would be exactly the same, so we're usually talking about one of these 3. Bell, peak in the middle, skewed right when the tail goes on forever to the right, skewed left, it goes forever to the left. Alright, so let's look at a histogram. This histogram shows the number of customers arriving during the lunch hour for 40 different 15-minute time intervals. Sorry, it seemed like a good idea this time, but that's really tiny. Okay. So, we can see this. How many times did 3 customers arrive? So if I want 3 customers, am I looking for a 3 on the x or the y-axis? X. Number of customers is on my x. How many times did we have 3 customers? Once. What was the most customers arriving during one interval? We had 11 customers during, or sorry, we had, how many customers is that? It's not 11 customers. 6 customers. That happened 11 times. So we were measuring during 11 different of our time intervals. We had 6 customers come in. Describe the shape. Okay. This isn't always a black and white thing. Sometimes the shape is a little difficult to determine. So if I think here's my peak, because that's my highest. Okay, we have, 1, 2, 3, 4, 5 spots to the right, 1, 2, 3, 4, 5 to the left. But we do have higher values here. So it's really a little bit up to interpretation. What would you call this shape? Yeah, I would say bell-shaped is the best. Sometimes bell might also be called symmetric. So those terms are interchangeable. Sometimes on my answer key, I tend to go back and forth. So if I say symmetric, that means bell-shaped. Means about the same on both sides. Could you make an argument for skewed one way or the other? Maybe. I mean, the tails don't really extend on. We do have this weird little peak here that makes it not truly bell-shaped. But I do think bell is about the best option to describe this data. All right. I want you guys to look at this one and see if you can answer the question. So our histogram shows how many gifts each student received in a party game. Answer these questions. List the classes represented in the histogram. The classes are these different rectangles. That is probably the one that I have not talked about. The rest of the questions you should have been able to answer, but the classes are a little bit more tricky. So it seems intuitive, like this one's 0 to 2, this one's 2 to 4, 4 to 6, 6 to 8, 8 to 10. But there's actually a problem with that. Do you know what that would be?
Well, you wouldn't know which bar to put each half of them in.
Right. So if you ended with 2 gifts, which bar would it go with? So we have to actually clarify these. Even though it's drawn 0 to 2, we have to end that bar before 2, and we're going to start the next one at 2, the next one at 4, 6, 8, and 10. Now, our ending could be a couple different ways. You could say 0 to 1, because are you going to have like 1.9 gifts? No. So if you wanted to call your class 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9. Is that my last one? Yeah.
Wouldn't it make more sense to do it the other way and be 0 to 2, 3 to 4?
So the reason we can't do that is the classes have to be the same. So the width has to be the same. If you do 0 to 2, that's a block of 2. 3 to 4 is a block of 1. So we have to make them evenly. If your data was something that had decimals, you might have to include decimals. So you might say it's 0 to 1.9. 3.9, 4 and so forth. So the classes are the rectangles. You just have to make sure one rectangle ends before the next one begins. The width is how wide these rectangles are. It's also known as the distance from the beginning of one to the beginning of the next. So what is my width here? 2. So the classes, we will practice that a little bit more, but just make sure it has to be clear if I give you a number which group it goes with. So you have to end one before you begin the next. If a student received 6 gifts, which bar would we add to? So if I took the 6, based off this information that we talked about, which bar would I put it with? The 6 to 7. We would be adding it to this bar. Okay, what percent of students received less than 4 gifts? So how many, let's add up. There, 2, 3, and 4. So how many do we have all together? right, do we agree with that? So then we want to know how many are less than 4. So how many of those were less than 4? 5.
33%.
So it's 0.3 repeating, or 33. 0.33% if you were really precise, or you could round it. Describe the shape. Here's my peak, right here. So what skewed is this? We don't have any points after our peak. Everything is smaller, so everything is to the left.
Would it not be, why did you think five people got?
Less than 4. So remember, this bar is everything. This is like 0 to 1 gifts, 2 to 3 gifts. So all of those people got less than 4.
I looked at it the wrong way.
Oh. I maybe should have clarified that before I had you do those questions. All right, is that one okay? Okay, I know we have some people getting ready to leave soon. We sometimes need to know the shape of our data. Later on in the semester, there's lots of statistical stuff we can do if the data is bell-shaped, but it won't work if our data is skewed. So we'll have to be able to get an idea of what our graph looks like before we know is this symmetric or not. We could make a histogram by hand, like make classes, make a bar graph, but that is super time consuming and we have other resources available. So I was going to show you how to quickly check on your graphing calculator if data was symmetric or not. All right, so on your graphing calculator, you are going to go to Sept. So it's like second row over by your arrow buttons. And we are going to edit, so enter. All right, we will use lists a lot, but I have some warnings. Do not delete a list. So if you stat edit. If there is data in here, you can go up and highlight the title and hit clear enter. Please don't hit delete, then it deletes the entire list and it messes up everything else and we have to reset the calculator, okay? So I'm going to clear out my list. Just go to the title, hit clear, enter, and it should wipe out everything. Make sure all your lists are blank.
How do you delete them? Or how do you do it? You cannot just hit clear.
Clear is good. Don't use the delete button. All right. So now what we're going to do is type in that data. So I'm putting it all in L1 for list 1. You're typing in those points in that table. It doesn't matter what order you put them in, so if you miss one, you can type it in at the end. It's not a big deal. Yes, sorry. We're put in L1, like you type a number and hit enter. We're just putting the same list. Yes. Don't do 2 separate lists, sorry. The data was set up like that just so our table was more manageable, but it all goes in one. We use both lists if we have like ordered pairs and X and a Y value. Okay. So, girls, my plan, I know you're getting ready to be dismissed, is to finish this and give time to work. So, if for any reason I don't get through everything and I push it back, I'll email you, but that's, I think we should. I'll just take your homework thing. this takes us into our stat plots. These are some different graphing things that you probably have not used before, except for making like scatter plots back in algebra. So I'm just going to go into the first one. I'm going to hit enter, it'll take me in. I need to turn it on. And then these are all the types. The third one over is the history. So on these, I don't know, is it 2 rows of things on that one? Yeah, so it's the last one in the first row is your history. Yeah. So hit enter there. As long as you put everything in your first list, the rest of the information here is correct. And if you go to zoom and number 9, it zooms stat. It will zoom to wherever our data is. So zoom number 9. It should show you a box plot.
What do I do?
Okay. Oh, you had second selected, I think. So make sure second isn't on and then do zoom.
Girls golf is dismissed at this time.
Yeah,
Girls
yeah,
golf
it's
is
the
dismissed
green.
at this time.
I don't no, not very much of anymore. Oh. Is that what it is? Yeah, I just, one of my goals is it, right? I'm not sure. Should I put that and then you click?
Yeah, not a big deal. Just make
Oh,
sure.
zoom.
Just zoom and make sure your second.
So did I have to hit enter?
There you go. You have to hit enter to select like the box for the histogram.
Okay, so hopefully it rains for you.
Is it supposed to rain?
Yeah, Kim was
It's supposed to
Oh.
rain?
she asked us all.
When's it
Is that
supposed to
Florida?
rain?
We didn't really like that.
Am I going to get rained on at a football game in Highland? That's my real question.
Wait, the middle school games in Highland is
Yes,
not here?
isn't that
Oh
awful?
my gosh.
Oh.
We gotta practice it.
You gotta go mow some hay down
What?
so it'll rain, we haven't rained like.
Yeah. Why haven't you been mowing that hay? Come on, it would have rained a month ago if you'd mowed
It's
your
supposed
hay.
to rain at one.
We lost a lot of
Thank
money.
you.
Hey man, I'm not good. I really think about it. Don't really wanna watch JV talk.
It is right here. Start rolling.
Plus, I'd probably get there, the game would probably already on.
All right, did everybody get a graph now?
Mark Twain sucks.
That's rude.
Sorry, Mark Twain's
Okay.
not very good.
So, what's the shape of this data? What do we think? Skewed left, we think? Yeah.
There's more bars to the left.
There's more bars to the left and they're higher. There's more points there. So I would definitely say
Skewed right.
skewed left.
Isn't skewed left, it's
Whoa.
higher, so if it's higher on the right side, it's skewed left.
But it's lower on the right.
We have more.
Lower points on the right side.
Think of it as how many points you have below your peak. So if I actually look, it looks like I have 2 above this, like 3, 4, 5, 6, 7 points below that. Okay, so you have more low points, so that's skewed to the left. All right. If this data was going to be divided into classes, beginning at 9 with a class width of 2. So the beginning at 9 tells me the first class. The class width tells me how far until I get to the next one. So the next one would have to start at 11. The next one would have to start at 13. Okay, and I only have to list the first 3, but I need to put their starting points. Can I just say 9 to 10 here? Look at my data. How many decimals did it have? 2. So we would have to say 10.99. The next one would be 11 to, this one would be 13 to,
Why does it have to be 0.99?
because the data in our table all had 2 decimal
It's
places.
happy to closest to that high list.
Yeah.
Just the first 3.
Yeah, you would have to keep going if you were listing all of them. I just didn't make you. So, huh? Yeah, yeah. It's good for us.
So it'd be 999 like all.
Mm-hmm. Yep, bunches of 9s. I probably won't do that to you. I'll usually stick to 1 and 2. But
Wait, what?
you never know.
No.
If Abram makes me mad, then on the test it'll have
I'm so
8
confused.
decimal
I'm
places.
so confused. What are you guys
Just don't
talking
say
about?
anything.
Nothing. Don't worry about it.
I
Okay, last thing I want to talk about.
don't make them all. I'm her favorite.
Stem and leaf plot. Do you guys, have you seen stem and leaf plots before?
Yeah.
This used to be something that was taught in like 3rd and 4th grade, but I swear the last 2 years nobody's ever heard of it.
I
So
don't think we ever plotted.
Isn't it like?
Do I look like that?
I don't remember hearing
it's when, okay. So if you have a stem and leaf plot, and it was like 1, 2, 2, 3, 2, 3, 4, 4, 5. That means my original points were 12, 12, 13, 23, 24, 24, 25. You put like the leftmost digit in the stem, and the leaf is like your 1 digit.
Oh, no, I see.
I
You
don't
guys haven't done
never
these?
done that.
Okay.
What?
Okay,
I
Let's get
so let's back up a little bit. We'll start with how to make a stem and leaf plot. Our crash course. So let's say I give you a set of points. Okay, those are my points. If I told you to create a stem and leaf plot, it's basically a shorthand for looking at this. Your
Zero.
stem is your tens spot. So the 1, 2, 3, but since I have a 6, my first stem would have to be 0. And you can't skip around. So even if I didn't have, like, let's say I added a 65 here. That means even though there were no 50s, I would have to put the 5, okay, to go all the way up to the 60.
So
The first digit.
this box definitely just
I'm so confused.
Okay, what are you confused with?
I don't know how we got the whole website.
It's the first digit.
The first digit. Alright. I pick up what you're putting down.
So if there's multiple 4s, there's only correct
There's no 5 up there.
For the stem.
But you still have to do it to get it to 60.
Okay.
The leaf is your 1's digit, but you put them in order, okay? So how many have a tens place of 0? That's just my 6. So I just put 6, okay? How many have a 1 in the 10 spot? Just my 10, so I put my 0. What about my 2's? I put
7, 9.
Okay, so we have to put them in order, 7 and 9. Okay, my 3's, we have just the 1. My 4's,
2, 7, 2.
and we'll put 2, 2, 7, just going small, increasing order. There were no 5's. I don't want to put a 0 here because then it would look like a 50. There was nothing, so we just leave it blank, and this would be a 5 for 65.
So it's not, whenever you write the order, it's not going from like left to right on the list, it's
You got
just
me lost.
smallest.
Yes, yes.
So is this actually faster?
It depends on what you need.
I suppose to be
So
like
this could also kind of describe the shape of the data, because I could see, if I were looking at this, I had 3 40s, so think about, like if you drew your,
Yeah.
this is kind of skewed to the left, I have more lower digits than higher digits. So you could use a stem and leaf to look at that. The other benefit of that over a histogram is your histogram can lose the original data points. If I look at this, I can say, okay, there were 3 numbers in this range, but do I know what 3 numbers they were? No, I've lost that. So if I need
Basically,
to,
that's a sideways histogram.
yep. So if I need to retain what my actual data was, I could use a stem and leaf. All right, so let's practice reading it. That is again very small. So the number of books read by students in a month. I'm sure you guys read more than this, right?
I read like at least 10.
So how many students read between 10 and 19 books? All right. So this was the number of books read by students in a month. So if you think about this data, this is saying we had 10, 11, 14, and 17, right? So how many students read between 10 and 19 books? 4 of them did.
How did you get those numbers?
My stem is 1, so 1, 0. It's 1-1, 1-4, 1-7.
My question is, how do you read 45 books a month? That's more than I'm going
Children's
I
book.
don't
If,
think we're taking
like
it
when I'm
literally.
reading to my 4-year-old and her
That is
bedtime
true.
stack of books is like 12 books.
every night.
Yes.
12 and
Who made this
crazy.
up? Like, how did you come up with?
No,
I just don't understand.
Reading
What's
this.
this?
Why
I
much
thought
free
this was like useful.
Still.
It's only useful if you have small
One
data.
story that's
If you
12.
have
It's like,
a
who
lot
thought
of
this was,
points,
like,
it's
really
not.
useful?
Usually, that's why it's usually taught like
Still doesn't
in
add up
elementary,
to 40.
but we
Yeah,
still
never.
see it
And I
sometimes.
I'd have been like, well, there's we did not
Okay, what are the maximum and minimum number of books read? Can you tell me the highest number on this chart?
45.
Can you tell me the
Two.
lowest number on this? Okay, describe the shape of the data. So where's my peak at?
1.
I had 4 in this group, right? So that's like my peak. So,
Skewed right.
So the most kids read
A ton of
10
books.
and 19 books.
Oh my gosh.
it must be
He's
the
gotta
other
be
kids.
elementary kids.
Yeah. So this is skewed right. We have more kids reading above our peak than below.
I read like the captions.
I'm gonna
Okay.
understand this now, but later I'm gonna be lost.
I want you guys to make a stem and leaf plot.
Okay. Got it?
Yeah.
0.
And I need to go up to what? Okay, so if I look at my 0, so we have to put the smallest first and then the others. So 3, 7, 7. Okay, the ones that have a 1, so my first would be
0, 2, 4, 7.
okay, the 2s.
0, 2, 6.
The 3s
1, 3.
and my 4s.
0.
5.
All right, is that okay? Better?
Oh, yeah.
Okay. Oh, did I say I didn't ask for the shape, but I could have it skewed.
Skewed right.
Skewed.